Section 6.6, function operations. We're going to add, subtract, multiply, and divide. We're going to find the domains of these functions, and then at the end we'll find the composite of two functions. I know you've done function operations before, so I don't think you're going to have trouble with this part. Sometimes people have trouble with the domain, but if you kind of know the steps that you take, that's not bad either. Notice how if you have the function notation written like this, like f plus g, and then in another parentheses x, it's just that you're adding the two functions together. So whatever they're defined as, add them together, and basically it's putting like terms together, and that's it. Don't make it into anything that it's not. Subtraction, same thing. So whichever one is listed first, that's the one you subtract from. So you do it in the exact same order that it is. Multiplication, a lot of times it's two functions with 2 or 3 terms in them, so you have to FOIL them, or the extended FOIL if there's more than 2. Division, the one that you see first is always on the top, the other one is on the bottom. Sometimes you'll have to factor to cancel out some things on that one. Usually you don't have to do a long division type thing. It's not quite that complicated. For that one, the one on the bottom cannot equal 0. That's the main thing that you're going to look at in that one to find out what the domain is. So that's kind of a big hint right there. Underneath it says the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both of them. So what we're going to do is we're going to look at each function separately, decide what the domain is, and then what would it be if we put them together. And that's kind of what we're looking at. Okay, so here's the first one. So we have two functions. One is 4x plus 7. The other is square root x plus x. They're looking for the sum and the difference. Okay, so f is listed first, so I'm going to write that one first. 4x plus 7. The book throws this in parentheses. You don't need them. They're just kind of keeping track of which function is which. And we're going to add the g of x function to it. Again, you don't need the parentheses because all we're doing is adding. And then if there are any like terms, then we're going to put them together. So anything go with the 4x? X. So I'm going to go 5x. Anything go with the 7? No. Anything go with the square root of x? No. For this one, if there's roots of things, it's harder to decide where those go. The book, I think, will put the x's first and then the number so that you kind of do the variables first and then the number. So I'm going to just reorganize them. It wouldn't matter which one of these x's you put first, but make sure the number is listed last. So that's my function. Now I have to decide, how do I figure out the domains of these things? Okay, so at the beginning, does it matter what you put into that? 4x plus 7. Could we go positive numbers, negative numbers, 0? We could do anything, right? Because it's just a line. So for this one, I'm going to just put above it all real. If you were writing this down, I would say domain of f, all real. Okay, so if you wanted to write it that way, like if you didn't have the question on your paper, you could write it like this. Okay, then we're going to do the same thing for g. So does it matter here what we put in for g? So can we use positive numbers? Yes. Can we use negative numbers? There's a square root. Can you use negative numbers? No. We don't want to go into the I zone here at all. If you can't do negative numbers, then don't list them. Could we do 0 though? We could. So we're going to do all real greater than or equal to 0. So we just basically can't have any negative numbers on that one because of the square root part. if it was just x plus 7 or 2x squared plus 5 and it wouldn't matter, then we could do anything. Now, what is the domain of the whole function? So we did them separate. Now we have to do the domain of the whole thing. Okay, what you do is you take the part that overlaps in them both. So all real covers everything, but the one that is more defined is the all real greater than or equal to 0. That's the one you pick. Okay, so if it is more specific than all real, that's the one that you pick. So I'm going to go all real greater than or equal to 0. So basically you're combining them both and you're picking the part that overlaps them both. Now, the good thing is if you have two questions that go with one, we've already defined them separately up here, the domain of f and the domain of g. Now we just have to define them together with a subtraction question. So for subtraction, f is listed first. They could switch them around and do g minus f. If that's the case, g goes first, f goes second. So it is 4x plus 7 minus square root of x plus x. So looking for like terms, notice that this negative does carry through to the second one. So it would be 4x minus 1x, so you get 3x. Minus square root x plus 7. Would the domain for this one be any different than the other one, like the total domain? You're looking at the exact same functions. All we're doing is subtracting. So if the domain of f is all real and the domain of g is all real greater than or equal to 0, it would be everything greater than or equal to 0. So it's still basically the overlapping part. So the domain here of f minus g, all real, I'll do r for real, greater than or equal to 0. Okay, so a lot of times the adding and the subtracting ones are the same. But you do have to be specific. It does ask you to do them for both. Now let's do the multiplication and the division. So f of x times g of x is what you're doing. X squared minus 9 times x plus 3. Two terms multiplied together, so we're just going to FOIL it. X squared times x would be x cubed. X squared times 3 would be 3x squared. 9 times x would be negative 9x. And negative 9 times 3 would be minus 27. There are no like terms, so I'm just going to circle it, box it, whatever you're going to do. So the domain of f would be what? X squared minus 9. Does it matter what numbers you plug in there? Okay, so think about this. If you put in a positive number, does it matter? If you put in a negative number, does it matter? No. You can have any real number there. And basically it's because it's squared. It'll turn any negative number into a positive number and it won't matter anyway. And it's just a parabola, and parabolas can open up, down, wherever you want them to open. So this one is going to be all real. The domain of g, this one is a line. Does it matter if you have positive, negative numbers, fractions, anything? Nope. Domain is all real. So if they're both the same, wouldn't the domain of the whole function be all real too? Yep, because there's not anything that is smaller. So the domain equals all real. So you have to think about them separately, and then if you overlapped them, would they be exactly the same? And in this one, they are. Now, the division one is generally not the same as the multiplication one. So adding and subtracting oftentimes are, but the division one usually is not. So for this one, they have f in the numerator, g in the denominator. So we will do x squared minus 9 over x plus 3. And now we have to try to do something with that. Can we factor x squared minus 9? Yep. Usually if you have the division ones, there's probably going to be something you can do. The middle terms cancel. So one is positive, one is minus. And what are factors of negative 9 that add up to 0? 3, negative 3, right? So this term cancels out with that one. It's not x's with x's and 3's with 3's. It's the whole entire x plus 3 with the other one that is x plus 3. So my answer is x minus 3. But what determines what the domain is? The domain of the top part is all real. The domain of the bottom part is all real. But when you put them together, what matters? Okay, and what matters is right here. That part cannot be 0, right? If I put a number in there, what would give me 0? Negative 3, right? So you go x plus 3 equals 0. X would equal negative 3. That's the one that we can't have, okay? Because you cannot divide by 0. So we're going to go all real. And I'm going to say x cannot equal negative 3. So even though it canceled out, it was still part of that original function. So you could almost do the domain first before you cancel everything out, because I think if you do it last, you might forget that it's gone. Okay, so always look at the denominator. That's the part that's going to determine what your domain is, especially if you have all real. Okay, does that make sense? So in the division ones, do the domain first. It's always determined by that bottom part. What if you have to factor the bottom part? Could there be two numbers that don't work? Yeah, let's say you had like a x minus 4 and an x plus 3. You couldn't have 4 and you couldn't have negative 3. So there might be multiple numbers that don't work, but just make sure you look at that first. And if it can be factored, do that first, and that determines what those numbers are. Okay, composite functions. I don't know if you guys did these, but I know you did the ones that we have just done. Composite functions. Okay, I think I copied the wrong one here. Yeah, this shouldn't be here because I already had that in there. I don't know where that. Okay, I'll just cross it out. So, and this one is super dark. Sorry about that. Composite functions, and I'm going to just write it below just so you can kind of see what it looks like if it's too dark from where you are. It's like a little like circle. It looks different than like a dot for the product. So if it's like an open little circle, here's what it means. And you'll know what that means here in just a second. It does give you steps in the concept box, but we are going to go through the steps here now. This is g of f of x. So the one that's listed first, you'd say it first. And it's just, if the f was first, you'd say f of g of x. What happens is, if you write it like this, it says we're going to put this function into that one. So we're going to kind of combine them, and that's the composite part of it. And then we'll have to determine domains probably after that too. Okay, let me see if I missed anything up here. The output of the first function becomes the input of the second function. Okay, so that's what we're going to do right now. So I'll leave that up here. Could they switch the letters around? Yes, they can use any letters that they want. The one that's on the right always goes into the one that's on the left. Okay, so F will go into G. There's two ways that you can do this, and I'm going to demonstrate both just so that you know what to do. If we use strictly the functions and not the number yet, that's this one. Okay, so what I'm going to do is I'm going to find g of f of x first, and then I'm going to put in my -3 last. This is not the way that I recommend. I just want you to kind of watch it. I think once you see it, you'll definitely do the second one, okay? So what this is telling us is I want to plug this function into this one, okay? So if this is my function, it stands for what x is, I plug it in for the x. If there's more than one x, plug it in twice. So this looks like x minus 5. I plug that in for the x. Now I need to square it. Okay, which gives me x squared minus 10x plus 25. Okay, and that's just foiling it out like there's two of them, x minus 5 times x minus 5. Now this one tells us that we need to plug in a 3, or -3. So I get -3 squared minus 10 times -3 plus 25. So I found the general thing first, and then I'm just going to plug in my number. So that is 9 plus 30 plus 25. $64. Okay, now that's kind of taking the long way around. I don't really like this one because I don't think it's one that you guys will do, but I wanted to show it to you anyway. So this is the one that I think you will remember. Okay, what if instead of going through all of this, we plug in the 3 right away, the -3, because that's what it wants us to do anyway. So I'm going to find out what is f of -3, which means anywhere there's an x, plug in a -3. And I get -8. Now, what the composite tells us to do is I want the answer from the first one plugged into the second one. Okay, so now instead of going through all the variable stuff, let's plug it in. So what is g of this answer? Okay, so now I go to g of x and it says I want to plug in a -8 for the x, and all I have to do is square it, and I still get 64. Okay? Now, what do you guys think? Second one, much easier? Much. And the thing with this is, if you mess up on the multiplication, you're going to get this one wrong. You're probably not going to mess up on the substitution part. So I like the second one better because A, it's less work, and I think you're going to make less mistakes that way. The only way you would have to do this one is if they wanted you to find just the function and they didn't tell you the number to plug it in. Okay, then you would have to do it like that. But if they plug in numbers or if they have numbers whatsoever, definitely plug it in whatever one is listed on the inside. And this one goes into the one that's on the outside. And they can do the letters in any order that they want. Okay, does that seem pretty easy? Good. Did you guys do this in Algebra 1? I don't think you did. I know you did functions, but I don't think composites were there. Okay, I'm going to skip that one for now. Okay, let's just look at these for the domain, because you guys can add the functions and subtract the functions, right? Let's look at the domains to see what we would have to do. And I'm saying the domain of the whole thing, okay? Would it matter what kind of numbers I plugged into f on this one? Positive, negative, doesn't really matter. Would it matter if it's a line? No. So for both of these, you're going to say all real. Now, you don't have to write them separately unless it really asks for them. What are the domains separately, and then what is the domain as a whole? If it just says what's the domain, you could do them separately kind of in your head or off to the side, and then you could put them together. I'm going to say for both here. Okay, and then you guys would definitely have to go and do the actual function part. What about this one? We're multiplying and dividing. If we're multiplying, does it matter what we plug into f of x? No. Does it matter what we plugged into g of x? No. So for this one, wow. Okay, would it matter when I divide? They're all real separately, but what happens when you put that 1 into the denominator? That's the one that defines what you can't have. So what I do then is I take that function, set it equal to 0, to find out what number do you plug in there to make it a 0, and we can't have that one. Okay, so on this one, off to the side, I would say 3x plus 1 can't equal 0. You can set it equal to 0, and then when you define it, say it's not equal to, but we can't have this one. So we'd say 3x can't equal negative 1, x cannot equal negative 1/3. So all real except negative 1/3. And that would be the division one. So the multiplication one, a lot of times it doesn't matter. I can't think of one, unless you have a square root there, then it wouldn't matter. If it's x squared, x cubed, the positive, negative part wouldn't matter. It's if you have square roots there. For the division one, it's whatever is on the denominator. That's the one that's going to define what you have. Let's do one more composite one. We're just going to do the number way. Now, notice, do these functions look the same? But notice what they did. They switched the letters around. So I want you to try this just on a piece of paper, on your assignment. It doesn't have to be a separate total piece of paper. Try this one, see what you get. You can do the long method where you put them together first and then substitute in, or you can do the short one. I would recommend the short one, but... Did you all get 4? Okay, so what we do is we look at the one that's on the right. This is the one that gets plugged into that one. So we found out what g of negative 3 was. It's negative 3 times negative 3, or 9. And we take that answer and plug it into the other one, or the one that's listed first. So when we plug it in, we substitute it in for x, which is 9 minus 5. So the composite function is 4. Super easy. You don't have to do anything else. Now, I want to do one more just to kind of show you that this can apply to word problems. So with this one, you have a coupon good for $5 off the price of any large pizza. So we're going to define that one. And we're going to do like a composite function with it. So we don't know how much the pizza is. So we're going to say let x equals the cost of large pizza. Okay, so however much the large pizza is, that's going to be our x. We have a coupon for $5 off. So what do you do with a coupon? We have $5 off. What do we do with it? Subtract it off. So we're going to do, the coupon is going to be the C part. So we'll say cost with coupon would be however much the pizza was, subtract 5. So makes sense kind of so far. Then it says you also get a 10% discount on any pizza if you are a student and show your ID. Okay, so the discount, we'll say discount is going to be your pizza times 10%, but then you also have to subtract it. So we're going to say cost of the pizza minus the discount. And that's like a 0.1x. That doesn't look right. 0.1x. Now, you could do the discount in another way, right? If you have a 10% discount, what's the percent you have to pay? 90. So if you think about it that way, you can totally do that. Because what is 1x minus 0.1x? 0.90. Okay, so either way is okay. And you don't even need the 0 here. So 0.9x. Now, what they want is there a difference if you use the coupon first or if you use the discount first. That's what they're kind of looking for. Okay, so we're going to do this thing kind of twice. Let's do the discount first. So, and by first I mean that would be the first function that you use. So when they're asking for the discount, I'm going to put it on the right. So we're going to plug the discount one into the other one. This one doesn't have numbers to plug in, so we can only do it with the functions. So looking at this, we're going to do 0.9x into the other one. Okay, we cannot do anything else. That's what it is. What happens if we switch them? This time we're going to put the coupon in first and then do the discount. So we're going to plug the x minus 5 in for the other. So it looks like this. That would be 0.9x minus 4.5. Yeah. Like I said, they haven't given us any numbers, but the question says, how much more would you pay? That means subtraction, if you get the coupon first. Okay, so the coupon one was which one? Which one was the coupon first? The bottom one, because you got to put the coupon into the other one. So we're going to do the bottom one minus the top one. And it's just asking for how much more would you pay, which is the difference, if the coupon is first. So we're just going to subtract these, and I should put that in parentheses. So it's going to be 0.9 minus 0.9. Those are going to cancel. And then you get negative $4.50 plus $5. So this would actually end up to be 50 cents, which in the grand scheme of life is not a super big deal. But if you're a couponer, it is a big deal. 50 cents is 50 cents. So you would save 50 cents if they did the coupon first versus the discount first. And for some, like if you were paying for something that was more than just a pizza, that's kind of a big deal. If it's just a pizza, 50 cents is not a big deal. Okay, so the one that is first is defined by the letter on the right. So for this one, I would pick this one first because the coupon goes in there first. And then I would subtract the other one from it. So if you happen to have word problems, you can use composite functions there as well.